Hello, I'm Bill Martin, and for the next 5 minutes I'll share a strategy for decarbonization of buildings called Moving Heat to and from Underground. The California Geothermal Heat Pump Association wants decarbonization using geoheat pumps in occupied buildings. Like the business card says, we connect to the Earth's thermal battery, and you can too. Geoheat pumps use the miracle of refrigerant compression, like your refrigerator or car's air conditioner. The difference is that geoheat pumps are anchored to an underground heat exchanger with a circulating liquid. Our connection to the Earth is like the posts on your car's battery, except that we provide thermal transfer. Our closed-loop pipes work within soil, rock, or water, transferring heat 3,000 times better than pulling it from or rejecting it to outside air. Air-based units usually struggle against the hottest or coldest outside air when working to cool or heat a building. Geoheat pumps work with a steady temperature underground. Efficiencies stay high around the clock and in all seasons. Successful decarbonization means dropping chemistry and embracing physics. Methane leaks before it's combusted and emits CO2 afterward. Why depend on a 3,000-degree flame to satisfy a 72-degree thermostat setting? It's not smart or green. Geoheat pumps work via conduction with the Earth. They transfer heat from and to underground renewably, without carbon. One unit of electricity imports or exports multiples of thermal energy, posting 400 to 600% efficiency. This resource is free and on-site. Since every occupied building has electrical service, no imported fuel is necessary. One piece of equipment provides heating, cooling, and hot water preheat. District geoloops can act like an energy highway, where multiple buildings or occupied units share a common loop. One building or section's cooling rejects heat into the loop and can serve as someone else's heating or hot water production. This reduces necessary heat exchanger capacity and capital cost. Boston's gas utility has 100-year-old leaky distribution lines needing replacement at a cost of over $9 billion. An engineering study analyzed the situation and pitched a geo-micro-district that's being built as a prototype. It's a solid revenue opportunity for the utility that's pollution-free. Other geo-micro-districts follow Austin's Whisper Valley with its 7,500 residences. This is the schematic for a geo-micro-district, or multiple zones in large buildings, where a central loop, referred to as a least energy path, provides the highest mechanical efficiency yet known. Stage 1 illustrates a balanced heating and cooling load that is self-supplied within a single building or zone. Stage 2 shows the central loop that is capable of sharing among multiple buildings or loads when they are imbalanced. Stage 3 represents activation of the geobore field to either warm or cool the central loop to remain within its limits. When the bore field cannot maintain those limits, the system employs Stage 4 as either a small chiller or boiler to correct it. Since 90% of a building's HVAC runtime is at 50% or less of maximum load, chiller and boiler use will be rare. This major subdivision is only 12 miles from the California Energy Commission's headquarters, yet its eventual build-out of 10,000 units of production housing is all supplied with methane. That's not decarbonization progress or climate defense. A district geoloop could have been installed for this development that would have matched the state's decarbonization policy. Such a step at Tuxedo Farms in New York State resulted in the district geoloop costing $16,000 less per housing unit than piping gas throughout. A combination of regulation plus consumer and developer education should have prevented Folsom Ranch from creating more emissions 14 years after we adopted AB 32. Now that all new California homes must be solar equipped, this project missed the easiest green opportunity of geoheat pumps. Decarbonization and the Earth's thermal battery is what we want to share, and we'd love to hear from you.